So we're now on part 3 of our redox exam style questions. As you can see, there are quite a lot. Okay, and we've got this one here where you've got 3 different half cells and you've got to find out what is the relative size of each. So they've set up them in these diagrams here and they deliberately make them a bit awkward. So you can see, for example, the anode is here on the left, but on here the cathode is on the left. So, but that's how it was set up in the exam question I looked at. Okay, so don't let that confuse you. So if we then go to the side, the question is just basically saying which one is the most positive of the redox systems, which is the most negative. So we're looking up at here and we've got to do some comparison. So first of all, let's have a look at the one on the left. So look at the one on the left. This is losing electrons. This is gaining electrons. That means that this electrode potential is more positive than that one. So that means CR is larger than Mg. So it's more positive. So CR is larger than Mg. So that means B is larger than A. Okay? So B is larger than A. So we'll look at the other one. Now chromium is in this one. Now this time copper is gaining the electrons. Okay? And chromium is losing. That means copper is a larger electrode potential than the chromium. So if that's the case, B is our chromium, copper is larger than the chromium, so that means the top one is C, and that means the bottom one is the magnesium, okay? And that's how you do this one. So we're now going to talk about the pH of a standard hydrogen electrode when it's added to another cell. The cell is magnesium, okay? And remember, the standard hydrogen electrode is set to 0. Which means whatever value for the overall system is there, that is for the other cell, not for the hydrogen electrode. So that means that cell has a value of minus 2.36, which means that is a lower number than 0, which hydrogen electrode is set to. 0 is a higher number, which means the hydrogen electrode will gain electrons. We'll come back to that in a second. The cell delivers a current and the pH increases. Okay, that means it becomes less acidic. The lower the pH, the more acidic it is. Okay, so explain in terms of electrode potentials and equilibrium why the pH of the solution increases. So let's just talk about this. So first of all, we said the equilibrium is going to gain electrons. So it's going to go in that direction because of this. Minus 236 is less than 0. So the 0, more positive, it's going to gain electrons. Okay, so it gains electrons from the magnesium half cell and the equilibrium shifts to decrease the H+. If you decrease the H+, it will increase the pH. So there's your 2 marking points. We're going to look at a standard hydrogen electrode again, but this time it's the same setup as we had in the previous question, but we want to know the pH of the solution in a standard hydrogen half cell. This needs you to remember what is the concentration, the standard concentration. Standard concentration of the H+ is 1 mole per decimeter cubed. So all we have to then do is, if we know that, is to put pH equals minus log of H+ concentration. The H+ concentration is 1. And if you put that into the calculator, the pH is 0. And remember, 2 decimal places on every pH means the pH of a standard hydrogen electrode is 0.00. So I saw this strange question and I thought there's something I definitely need to show you. So the Cn- ion is the conjugate base of a very toxic weak acid. So beware what is hidden in the question. It says very toxic. That's your big hint. Acidic conditions should not be used for cells containing Cn- ions. Explain why. Now, it makes sense that this would create HCN. Okay, and we'll show you that in a second. So basically, what you've got is the Cn- ion, which is there, and if you add acid to it, acid is H+, you would make HCN. And if you make HCN, HCN is toxic. And because it's toxic, it's not a good idea to have acid against and with Cn. So in this question, we're going to go over how a species can act as an oxidizing agent and a reducing agent. This is very similar to if you do one on catalysts. So in catalysts, you need to be used up and then regenerated, which to do that, you need to be oxidized and reduced, you see. So therefore, most of the time anyway. So basically that means here is exactly the same type of question. So if you can do this, you can do the other one. So Cr3+ can behave as an oxidizing agent. Oxidizing agent gets reduced. So it gets reduced. So it gains electrons. A reducing agent gets oxidized, so it loses electrons. Okay, so losing and gaining. So we've got to see where we can get Cr3 plus to lose and gain electrons. Now if you look down here, you can see Cr3 plus is here and it can gain. And you can see it's here and it can lose. So I need to make sure for this one that there's something more positive that can gain those electrons to force chromium-3 to lose. So I'm going to use the top two. For this one I need chromium-3 to gain. So I need something else to lose. So I need something that's a lower electrode potential, which is this one at the bottom. So looking at all of that, I can take out all the stuff I don't need, and I've got the stuff I need here. So let's go through the bottom one first, 6 and 7. And you can refer to them as their numbers sometimes in the mark scheme. So if you don't want to write it all out, you say 6 does this, 7 does that, 1 does this, 2 does that. So basically, if you look here, first of all, I'm going to just say what an oxidizing and a reducing agent is, and say what it does. I've said that already. Then I'm going to say chromium-3 oxidizes Ce. So the chromium-3 oxidizes Ce. You can see it down here. The Ce is oxidized, so the equilibrium is going that way for the Ce, and it's going this way for the chromium. Then, after we've done that, it says overall equations as well. So let's put an overall equation. We just balance the electrons, 2 and 3. And this video is not about balancing equations. I expect by the time you get to this point, you can balance these equations. Okay, so that needs to be 6 electrons, that times 3, that times 2. We can see it here. Now, that means, I'll go down here, okay, that the electrode system of that is more positive. So we do a comment on which one's more positive, and we do a comment on what's oxidized and what's reduced, and we give our equation. Now let's put that to the side, okay, and we're going to do our other one. So our other one is the manganate and the chromate. So the manganate is going to gain electrons, the equilibrium is going to go to the right, and the chromium-3 is going to lose electrons, okay? So remember, we're getting it to act like an oxidizing agent or a reducing agent. So a reducing agent loses electrons, so this is our reducing agent moment, and this is our oxidizing agent moment. Okay, so first of all, acts as a reducing agent. And a little points, when you're talking about the half equations, you've got to include both. So include both the hydrogen and the manganate, okay? And acts as a reducing agent. We're going to do a comment about what's less positive or more positive. So basically it's less positive than the manganate. You see the number is larger here. Okay, and we put our equation in. This is a monster of an equation, which you can see. Okay, and if you don't want to know how to do these, go into the balancing redox equations and combining redox equations video. Okay, but all we've done is we've made the electrons the same by timesing this one by 6, top one by 6, and bottom one by 5. Then we've cancelled out our hydrogens, cancelled out our waters, and we ended up with this beautiful long equation here. Okay, now you will get a mark for everything. So a mark for this, 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 mark for this. 6 whole marks. Okay, so make sure you can do this type of question because it is always put in there to make it difficult for you. So our last question is going to be on cell potentials, and it's an MCQ. Now it just wants you to recognise which of these 4 statements is correct. Okay, now we do this by looking at the values which are given up here, and we first calculate which one of these is correct. Okay, you see minus and a plus. So basically here you have minus 2.36, minus 0.14. Minus 0.14 is a larger number, so it's a more positive number. So it's the more positive number minus the more negative number. So minus 0.14 minus minus 2.36, which is minus 0.14 plus 2.36, which is 2.22. So our answer is C or D. So if it's C or D, we then need to go on the magnesium. The magnesium is losing electrons, which means it's being oxidized, and the tin is gaining electrons because it's more positive, and so it's being reduced. So that means the magnesium is being oxidized, so the answer is C. Okay, now I've gone through in these 3 videos, I've gone through all the kind of questions I could find on electrode potentials and made sure you know every single last one of them. So I really hope it has helped. Okay, as before, please like, subscribe and share. More importantly, share to your friends in all your different schools and things like that, because I just want these videos used as much as possible. Thank you.